Yo, what's up, YouTube? It's a crackathon, video. It's a I have I have an as the title is read. I have an assignment in presentation in 30 minutes. Gotta look into it. The lights. What do you do? So that was it. Was the presentation was at question number 78. That shit was funny. Not gonna lie, but it was serious. Not gonna lie. 78 ist das die Problem, dass ich muss antworten. Jo. Oh no. This one is assignment 10. $78. Yes. So, what was the question? Whoa. Calculate the volume of potassium hydroxide solution that has added to reach the equivalence point of titration. Volume of KOH at equivalence point. So what I wrote for the last week was the volume of KOH needed to be added. Oh, that's so bad. Has to be, yeah. Has to be added to reach equivalence point of titration. Has to be added to reach equivalence point of titration. Equivalence point is the stage in titration in which the amount or moles of acid equals moles of base. Could I say at equivalence? Mhm. Okay, the amount of moles of H plus from acid equals in which they have completely reacted with each other in a 1:1 ratio. So in this case, both the acid and base are strong, which results in a pH of 7 with the neutral salt and water as part of the solution. Balanced in this now specific for this case, the acid and base involved in the reaction are strong. They're strong, therefore the pH is gonna be near to the value of 7, or it's 7. But this can change according to strong or weak acid in the solution. Mm, Now the for balance equation. Oh, it's just an equation. I don't fucking matter. Number of moles of HCl equals 1.157 into 10 raised to minus 3 moles. At equivalence point, the number of moles of HCl. Since both the HCl and KOH have strong electrolytes fully dissociated at equivalence point, the number of moles of H plus from the acid equals the number of moles of OH minus from the base, resulting in neutral water. So, what? At equivalence, also from the last part, you could say, as you can see from the addition of after the addition of potassium hydroxide into the hydrochloric acid, between 15 and 20 milliliters, the pH changes significantly, and equivalence point is a stage. So, number of moles at equivalence point. Calculation, yeah. The amount of moles, the amount or moles of H plus from acid is equal to the amount of moles of OH minus from the base, in which they react in a 1:1 ratio, forming a neutral salt and water as part of the solution. Both these acids are strong. It's the equivalence point. At equivalence point, the volume of KOH equals number of moles of KOH by concentration of KOH, which is 15.07 milliliters, which that is the equivalence point. Potassium hydroxide was added to another hydrochloric acid solution with unknown concentration. 10 milliliters of HCl plus 30% pH of 7. Therefore, the moles of HCl equals moles of KOH. In aqueous solution, hydrogen ions actually exist as hydronium ions. So when we say the acid contributes H plus, we mean it increased the concentration of H3O plus in the solution. At equivalence point of strong acid-base titration, H3O plus and OH minus concentration are equal, both coming from water itself, resulting in a pH of 7. H2O gives an aqueous solution as hydronium. At equivalence point, concentration of hydronium ion equals to concentration of hydroxide ion. So hydronium Okay, what else? What else? 10 milliliter of HCl plus 13.75 milliliter of KOH gives a pH of 7. That means that they're at equivalence point. Therefore, the H plus and OH minus are equal. Concentration of HCl equals number of moles of HCl by volume of HCl. So 1.4 to 10 raised to minus 2. Number of moles of KOH is volume into concentration. Equivalence point marks the moment of complete neutralization. I did not complete that part. Come on. Moment of complete neutralization, which is when the amount of added base exactly equals the amount of acid originally present. Equivalent point moment number of moles of zero equal, resulting in a complete neutralization to form water. Which results at equivalence point. Is the moment stage at which the hydronium ions and OH minus are equal, which results in a complete neutralization. I almost got it. I almost got it. So my problem with the hydronium ion is hydronium ion. It's so weird. I think I'm almost about to hit to glass, maybe. So, how do you start with? So the next part of the question is how much volume of potassium hydroxide should be added to to reach the equivalence point. Equivalence point is a stage in titration in which the amount of H plus produced by the acid is equal to the amount of, can I say, number of moles of H plus produced by the acid is equal to the number of moles of OH minus produced by the base, in which they're reacted completely with each other, neutralizing each other in a 1:1 ratio. And in this case, the acid and base are strong. Therefore, the pH at the equivalence point would be 7. But this can change according to the strength of the acid and base that are reacting into solution. The acid and base included in the solution. This can change according to the strength of the acids and bases. The pH at equivalence point can differ slightly based on the strength of acid and bases. So that's the question. Could you explain on a molecular scale on water's autoprotolysis for this? After this class, I need to register for my courses in your Budweis. What the fuck is this bit? What if I tackle you? Welcome. Should be good. Yeah. Peace out, people. Especially YouTube. I'll be doing my physics assignment after coming back from work. Not just physics. I just took a bit of more shit to do and gotta cook. Oh man, got a lot of stuff to do. Gotta buy a plunger. Yeah.